Let's dig into recursive structures and processes by picking up from the example we just put together in the previous lesson in code, where we're defining a singly linked list, and that definition is in this node class. And this is a recursive structure because one of its attributes, notice this next attribute, is referencing the same type from within itself. So a node can reference a node, can reference a node, until we finally reach the termination of a linked list, which is a none value. At the very end of our list, the very last node that has a value, it will have as its next a none value. And that's how we know that the list is ended. And this pairs really nicely. In fact, recursive structures are often most beautifully processed with recursive processes. And this is a recursive function definition. We know that because this call right here, notice it's calling the same function within itself. So before we follow this out entirely, I think this video is going to make sense in your work, make sense to break down into two steps. So I'm going to ask you to try and complete line 21 first and then line 22 second. Now I've gone ahead and fast forwarded to the point of reaching line 21 in on my screen here. I want to point out one other thing that I'm going to do before you pause, and I'm going to encourage you to try doing as well, which is when you're constructing these nodes, of course, you want to construct this node first, this node second, and this node third, because that's the order in which the parentheses are telling us to, and that's the order in which Python would. Normally we would say, ID 2 here, ID 3 here, and ID 4, and these would be nodes, right, which you're going to be constructing. I'm going to ask you to, for the purposes of this video alone, try reversing that order and putting your ID 2 at the bottom, and then ID 3 just above it. So if I were to try and rearrange this, ID 2 would come down here, ID 3 would come here, and ID 4 above it. And so doing this will have a reason. My thinking on why we're doing this will make sense when we get there, and it's not a requirement. Of course, the locations of these don't actually matter. It's only the references that matter. But this will help motivate the recursive process later. So go ahead and pause the video here and try completing this in your diagram. All right, so we can use the shorthand constructor here, but I'll point out that this is one of the reasons why we keep track of, when we reach this constructor call here, and this is the first one we process, we look at what is node. Well, node is ID 0, that's bound to a class. That's different from what this is going to be, a function call. ID 1 is bound to a function. And we know that when we call a function on a class like this, of the class's name, bound to a class definition, that's when we go through our process of constructing a new object. And so here I'm going to go ahead and follow our shorthand convention where we have node and we're calling init, and its return address is line 21, and its return value is going to be the next ID. And so we set up this next ID, and let me get out of the way here. ID 2, and again, this is arbitrary that I'm putting it down here at the bottom. I'm doing this for reasons that we'll see in just a moment. So this is a node, and its value is going to be 301, and its next is going to be none. So this is our final node. Let me write none here, not node. This is our final node in our linked list. Right? This is constructing effectively a linked list of length 1. Boom. All right. And so what that means is, as we're evaluating this expression, we return this to the same line. And so this is effectively ID 2. So now we are going to set up another node init frame. So node init. So the constructor is getting called again. We're going to use the shorthand again. Return address is line 21, and return value is ID 3. That's going to be the next ID on this heap. So ID 3 is a node where the value is 210, and the next this time around is this what we just evaluated here, right? So it's going to be ID 2. It's a reference to the next node in this linked list. And okay, well, that means that if we think about, this is line 21, so this is processed, and now we have, these two constructor calls. Oops, let me use red here. These two constructor calls, and these evaluated ultimately to ID 2. And finally, we have the outermost. So let's add one more frame here. So node init, and the return address is 21, and the return value is ID 4. Okay, so ID 4, node, value is 210. Oh, sorry, value is 110 in this one. And the next is ID 3. All right, so after we've constructed these nodes, this means that this whole statement here and I apologize, I wrote for this. This would actually evaluate to ID 3, right? And so we constructed node 110 with next of ID 3. That's what this outer one, I accidentally wrote 2 there. And this whole construction led to the evaluation of ID 4, right? And so ID 4 is what courses would be assigned. So just to break that down, because I had that little bit of scribble there, let's go through this one more time. This call led to ID 2, that object, right? This call led to ID 3, and this call led to ID 4. And we see that, right? So this is ID 2, this is the node value 301, 210, that's the ID 3, and then 110 and 110, that's ID 4. Right, and so we have our list, and courses was ultimately assigned ID 4. So courses has this reference to this node has a reference to its next node, this node has a reference to its next node, and finally, this is the end. And this is how we get this linked list, right? So the head of our list is this node, and we're chaining these nodes together until finally we reach the end. And this is a recursive structure. You can notice that we can make this of arbitrary length, but we always have to have a node, a terminal node that has none as its next value. Cool. So at this point, we're ready to try processing the recursive function call, recursive sum. And I'm going to encourage you to pause the video here and see if you can carry it out. This one will take a little bit of time, and you have to be careful. It can be a little confusing. This is why we keep track of frames and function calls in this, using the rules that we know and love. So be sure that every time you reach line 18, which you'll reach it a number of times, you are establishing a brand new frame and remembering that your frame context will move to that frame. So your current working frame will be whichever one you just added, and then you'll jump back up to line 15. So go ahead and give that a shot and see if you can pull that together. All right, I am going to clear some space here just for my purposes, and I'm going to just, make a little note here of init elided. We did have to reach this point, but for the purposes of keeping all this together on one screen, I'm just going to compress those frames down. And now let's think about this first call on line 22. So we reach this call, and we should go ahead and fully evaluate our argument here. So this courses argument in our current frame is ID 4. Right? So that's what courses is. It's the reference to the node whose value is 110. And we're calling recursive sum. So we add the frame for recursive sum. And the return address is, of course, line 22. And our x's is ID 4. Right? That's what we just figured out that argument would be. Cool. So we jump into this frame and we see, okay, if x's is none, well, we look in our current frame, and keeping track of your current frame is going to be important. So I'm going to use this caret here to indicate the current frame. And our current frame, let me actually see if I can, there we go. X's is ID 4, so x's is not none, that's false. We go to this return statement. And this return statement, we first need to figure out, well, what is this? We always need to fully evaluate our function calls. What is this value? Well, let's fully figure out what is our argument here. So our argument is x's.next. Well, our current frame is this one. X's is ID4, so we look at ID4, and its next is ID3. All right, so what we're doing here is we're calling recursive sum on ID3. Now this is a brand new function call we're establishing. So let's go ahead and push a frame for it. So push a frame, recursive sum. Return address is line 22. Sorry, is line 18. That's the line we're processing, line 18. And X is this time around is ID3. Right? So notice we're not jumping into this frame yet. This is just before we jump into the frame. We fully established this frame. And to just make a quick point, so we're on line 18, and first we need to figure out what is this going to be. So this is where our recursive step is happening. And notice this is sort of, if we were to think about this at a high level, we're saying the sum algorithm is my current value, which would be 110, plus go sum the rest of the list and deal with that recursively. Deal with that outside of this function call's frame. That's not my concern. That's some other function call, the recursive function call's concern. And so we're setting up the frame for this recursive function call and giving it the next node. So notice we're moving. This first call to recursive sum process this node. This next call is going to process this node. We haven't gotten there yet. And let's keep carrying forward. So let me get back out of the way here. And we've established this frame. But now our current frame, we're going to jump back up to line 15. Right? So this is where we're going to process next. But our current frame is moved. Right? Now that we've established this frame and we've jumped into this frame, this function definition, our current frame is always the lowest frame on the stack that hasn't returned. So we're now in this frame. X is ID3, so it's not none. We go to the return statement. And again, we see that we need to process this recursive function call. Well, X is in this frame is 3, and we look in 3 and we see that its next is going to be 2. So ID is 2 here. And we need to follow and we need to push another frame. So we push another frame. And here the return address is line 18. This time around, X's is ID2. And we're ready to jump back to line 15. But first we need to recognize that our current frame has moved. Now our current frame, oops, I didn't write in, let me write in the name of this function. I skipped that. So let me make myself some space here. And this is, of course, a recursive call to recursive sum. Notice at the same time, just like we saw in VS Code's debugger, we have 3 frames on the stack at this point, all for the same function. But notice they have different contexts. They have different frame values and local values within it. This time, X's ID is 2. And so we jump back to the top and we test, is X is none? No, it's still not none. It's ID 2. So we once again, this is starting to get a little bit redundant. But we reach this function call on the return statement on line 18. In our current frame, though, we look at X's. So X's is ID2. We look at ID2 and we see that its next is none, right? So in this call, in the current frame that we're working in, this value is none. And this is important. So we push one more frame here. I'm going to give myself a little bit more space. Push one more frame and recursive sum. This time around, return address, line 18, and X's is none. All right. Now our current frame is going to be this one. All right, so let me delete this. And we jump to line 15. Just like always, when we reach a function call, we set up the frame for it, and we jump to the first line in that frame. So here we're reaching a base case. Notice this time around, if X's is none, we look and we see, yep, X's is none. So we're going to go into the then block of this recursive function call, and we return 0.0. I'm going to write my return statements, my return values in, let's say, red to highlight what's going on here, because this is one of the important ideas. So our return value at this point is 0.0. And if we think about this, again, at a slightly higher level, we're calling recursive sum where X's is none. And this was that base case we talked about. When you're summing an empty list, 0 is the sum, right? So this is our simplest frame, our simplest case. and we're returning 0.0 to line 18, right? So let's actually trace through this and this is the important concept to understand. So we're returning this evaluated to 0.0, but notably our context changed, right? So our current frame is no longer the frame where x is none. Our current frame is the lowest frame on our diagram that is yet to return. And so the context is important here. We look at this context and we see, okay, we just evaluated the return value from that function call is 0.0. Well, what is x's dot value? X's is ID2, its value is 301, right? So this expression, 301 plus 0, and we enter its return value in the current frame. So our current frame is this one here. So return value 301.0. As soon as that frame returns, what are we doing with that value? Well, we're returning it to line 18. Line 18 is actually the same line that we just called, right? And this is where it can feel a little bit confusing. So recursive sum would be 301.0. But notice, because we return this, our context changed. You know, these frames don't just fall out of coconut trees. We move back up. And here in this frame, in this context, x's is different. So when we go and we ask, okay, we got to finish this return statement out, but the context is now the frame where x's is ID3. And we say, okay, for ID3, oops, didn't mean to highlight that. For ID3, we look at its value, it's 210. So here, x's dot value 210. So 210 plus 301, that's 511. So return value here, 511. Okay. Well, we return that to line 18. That's the same line we're processing, but our context is changing, right? So this is 511 for this call. And our context changed. So we've returned from this particular frame. Let's move our current frame up. Our current frame is now this one. And we look at, okay, what is x's dot value? So x's is ID4. We look at ID4, its value is 110. Right? So 110.0 plus 511. And this return value is 621.0, right? Where are we returning this to? Notice now we're not returning this to line 18. We've reached the final frame for recursive call. This is the frame that we started with, right? This is where ID was 4. This was the start of our list. We're 110. And so we're returning this back to line 22. Well, line 22 is here. So this function call, recursive sum, evaluates to 621.0. And because that's printed, this would also be our output. Right? And we saw that in our example. And when we would return back to globals, of course. And here in globals, we would have nothing left to do. So I want to point out structurally something that's kind of interesting. Notice, and I'll use green. Okay. Notice that the first time we called recursive sum on courses, we called it on ID4. And so this frame was concerned with summing this particular node and then the rest of this recursively. And so, this frame was concerned with this node, this frame was concerned with this node, this frame was concerned with this node, and then finally our final frame was none. And so I'm actually going to I'm gonna try and make this avoid this being too crazy looking, but notice that this frame processed this node, and then we moved on the next frame, processed the next node, the next frame, processed the next node. And so in a sense, the recursive process mirrored or is a reflection of the recursive structure, right? Notice we're moving node by node, we're down through it, but we have to work our way back up in the opposite direction. So what do I mean by this? Well, it's as if we start by taking this first node and conceptually saying, okay, it's 110 plus the sum of what comes after me. Well, that's 210 plus the sum of what comes after me. Well, that's 301 plus the sum of what comes after me. Well, that's 0. And then we got to work our way back up, right? And so notice we are working our way down, and then the sums work their way back up, right? And that's because how we implemented this recursive process. We'll see another way of doing this where we actually pass the sum down through an argument rather than just through the return value, and have a different base case as a different way, a different approach to recursion. But here, the big idea is these two concepts are intimately related with one another. A recursive structure is often very beautifully processed with a recursive function definition or method definition. And we see that exemplified here. And notice that this is it appears to be a very simple function, but it results in quite a bit of work. And we're having to keep track of quite a few things. And this is one of the reasons why we use these diagrams. We won't be diagramming this, we're going to try and keep these diagrams a little bit simpler because this is a lot of work to move through as soon as you have those init frames and these recursive frames. But this is what's going on behind the scenes, and we saw this playing out in our Python debugger. So great work working through a recursive structure and a recursive function call. And we'll be taking a look at another alternative approach to this very soon.